All right, today we're going to talk about exponential growth and decay applications. This goes with 9.2a with Algebra 2. This is the equation for the growth model, and these are the variables that you need to know for the growth model. So it's y equals a times 1 plus r to the t, where a is the initial starting amount, r is the percent increase. It does need to be written as a decimal, that's important, and t is time in years. So those are the three variables that you need for this growth model equation. And then y shows, so y is the value after t number of years that it's increased up to. Can't talk apparently. So here's an example using the growth model. A business had a $10,000 profit in 2003. Then the profit increased by 25% per year after that. What was the profit of the business after 10 years? And write your answer in a complete sentence. So first it said write an exponential growth model, or write the equation. So the model will look like this. We can define our variables. A is the starting value. So here we started with the $10,000 in profit. It increased by a rate of 25%. We're going to need to use the decimal for that. So you move the decimal 2 to the left, so it'd be 0.25. And then, so that's the information we need to write the model right here. So then it's y equals the starting value times 1 plus the rate to the t. And I can simplify that a little bit by saying that it's 10,000 and 1 plus 0.25 is 1.25 to the t. So this is the model that represents this situation. The business is growing at 25% per year. So increased tells me it's growth, and then 1 plus r shows me in the equation that it's growing. Next, if I want to say what was the profit of this business after 10 years, well, that would be if t equals 10, y equals the profit. So y equals 10,000, 1.25, and then plugging in 10 for t. Then finish solving for our profit, which is represented by our y variable here. Following the order of operations, do 1.25 to the 10th power first, and then take that times 10,000, and you're going to get 93,132.26. So I rounded to 2 decimal points since we were using money, so that's $93,132.26 for that example. So West Fargo's population is right now about 35,000. It's increasing by 8% each year. That's an estimation. I think it's going up even faster than that. What will the population in West Fargo be in 9 years? So again, I know that it's increasing, and our equation is using addition here, so that tells me it's increasing. 35,000 people this time is my starting value. It's increasing by 8%, so I do need that as a decimal, so you move your decimal point over 2 places, so it's going to be 0.08 as a decimal. And so the model, the general model is 35,000, 1 plus 0.08 to the t power. Or if I combine my like terms inside the parentheses there, it'd be 1.08 to the t. Now if I want to know what the population will be in 9 years, then I plug in 9 for t. And this time y is representing the population. So y is going to be the population after 9 years. So I'm going to take 1.08 to the 9th power first, and then times that by 35,000. And I did the math previously here, so we're going to get approximately 6 69,965. I do get 0.16, so I'm going to round to the nearest people. So I rounded to the nearest whole number. And then you'd write yourself a complete sentence. So the population in West Fargo would be approximately 69,965 people after 9 years if it continued to grow like this. That could be an example of a complete sentence. It's hard to write on here, so. All right. So these were both examples of something increasing, population increasing, the value, profit increasing, a business's value increasing by 25%. So now we're going to look at some decay examples. And the decay model is very similar. It has the same. A is the initial starting amount. R is the percent. It has to be in a decimal. T is time in years. The main difference in the decay model is that it's subtraction in the parentheses instead of addition. So in the growth model, it's 1 plus R because it's increasing by that rate. So this 1, and we use R as a decimal, it's kind of like 100% plus that rate of percent increase. So in the growth model, you're growing. So if you're growing by 8%, you're really increasing something by 108%. In the decay model, you're subtracting from 100% by the rate. So it's like 100% and it's decaying by 25%. Then your rate is at 75% in the middle here. So the 1 really is representing 100%. So that's why we need to make sure we put our percent in decimal. So main difference is that decay is subtraction. All right, so let's look at a couple examples. Here's a common example when you take medicine or when you deal with chemicals. The amount of grams of iodine after T days is given by this equation. He wants to know the initial amount of the substance and then how much it's decaying each day. So iodine decays naturally. So how much did we have initially? Well, remember that in our equation, A represents the initial value. So if we look at our model, 50, and it's in grams, so 50 grams will be our initial amount that we had. What percent of the substance decayed each day? Well, in our model, this rate is what tells us what percent decreased each day. So in here we have 0.92. So if you think you started with 100%, now you're at 92%. Just a little mental math tells you that it decayed by 8% each day. However, if you're unsure the mental math, you can say, well, 1 minus R, that was what was inside the parentheses, equals 0.92. And then you can solve it algebraically. So you'd get negative R equals negative 0.08. So R equals 0.08, which as a decimal is 8%. So I was thinking of it in the middle, has to be 100%. What's missing is 8%. We'll do one more where we just plug into the decay model. This is the one I was thinking about with the medicine, with the ibuprofen. So if you read the back of Tylenol or ibuprofen, it says take 2 tablets every 4 to 8 hours. Well, what happens is the substance in your body is broken down over that amount of time. So at the end of 4 hours, the value is lower, so it's been decayed, so now you can take more. So that's why they put those warnings on there, and that's kind of how it works. So you can use a decay model to find out how many milligrams of ibuprofen is in your body if you know how much it decreases by or how fast your body breaks it down. So you can use the decay model here. So if you take 400 milligrams of ibuprofen each hour, so this time our T is going to be in hours, and it says that it decreases in our body by 25% per hour. So A is going to be the starting value, the 400 milligrams. Instead of using T, we're going to use H, which is not a big deal there. And then R is going to be our percent that it decreases by. So it's decreasing by 29%. And we will have to use a decimal 0.29. So our model will look like this. It's 400 milligrams, 1 minus 0.29 to the h power, so per hour. Or simplifying, 1 minus 0.29 is 0.71 to the hour. Then our question asks us how much will be in the system after 3 hours. So that means that our y here represents the amount of ibuprofen left in your system. So if I plug in 3 hours, so 0.71 to the third power, 71 hundredths to the third power times 400, you end up with 143.16, and that was going to be in milligrams. So that's how much is in your body that's left. So writing our answer in the complete sentence might sound something like this. After 3 hours, I have 143.16 milligrams of ibuprofen left in my system. And then that might be a safe time to take more. Not that that need to be in your sentence, but okay. You know, I've done quite a few examples. If you wanted to end the video here, I understand. A really common decay problem, though, is with your buying a new car. So cars decrease by value very quickly. They actually decay by value exponentially. But if you know your value of your car decreases by a certain amount and how much you paid for it and how many years, you can estimate how much it's going to be worth. So how much is the car going to be worth after 10 years? Well, if I know that it started at $25,000 and it's decreasing by 10%, so remember that's going to be 0.10, and I want to know after 10 years, that would be the equation that I use. It's going to be 25,000, do PEMDAS, so order of operations, you do what's in the parentheses first, so 0.9, then you do exponents next, then multiply it by 25,000, and I got the value of the car was approximately $8,716, and I rounded to 2 decimal points, 96 cents, because we're talking about money. I'm going to skip that last example otherwise. Okay, so let's just recap. We got growth equation is going to be y equals a 1 plus r to the t, and decay equation is the same thing except for it's 1 minus r to the t. T is time, usually given in years unless specified. A is starting value, and r is the rate, and you need to make sure to put that in decimal form. Otherwise, you will not get the correct answer. Thanks for watching.